turn it, leave it, stop, format it, touch it, bring it, pay it, watch it, turn it, leave it, stop, format it, touch it, bring it, pay it, watch it, turn it, leave it, stop, format it.
Let's go. We're back, part 2. Let's take a look at what we got here. In this question, we are told about a Mountain Lake High School. And in this Mountain Lake High School, we see that the students take math and they take physics. And out of 90 of these students, we're looking at their scores from both classes, and it's asking us, is there a correlation? So we have a task. We have to figure out what the correlation coefficient is, and then we have to determine if this correlation coefficient or what it means in the context of the story. All right. So most of you guys know, 100% of the time I'm going to say, get your calculator out. Go to stat. Put it into our stat editor. Okay? All right, in this case, if you did that, following numbers would have presented themselves. Okay? All right, 55 corresponds with 66, 93 corresponds with 89, so forth and so on. And what do I have circled? I have circled the correlation coefficient, and it's 0.92. Well, the question was, state the correlation coefficient to the nearest 100. So to the nearest 100, it would be 0.92, and we would round down, so it would just be 0.92. And the next question would be, what does the correlation coefficient mean in this situation? Well, here's what it means. It means because there's a strong relationship, 92 is pretty close, 92 cents is pretty close to a dollar. There's a strong relationship between the math and the physics grades. So in English, that means if I'm rocking in math, I'm probably rocking it in science. But if I'm bombing in math, I'm probably bombing in science too. So the relationships are strongly correlated. All right, next question. All right, we had a word bank, and in our word bank, I asked you guys to give me what strong negative correlation looks like, what strong positive correlation looks like, and what does no correlation look like. And I gave you a word bank. And I'm hoping that we're good with this, that 0, it's got to go with no correlation. Negative, it's got to go with negative. Positive's got to go with positive. So this should be easy. It should be easy peasy. And I'm also hoping that when we see something that says strong positive correlation, we get the fact that as one variable increases, so does the other. When we see something that says negative or strong negative correlation, what that should mean is that as one variable increases, the other variable decreases. Okay, so let's take a look at this idea of causation. What does causation mean? Causation means when a change in one variable occurs, it affects another variable. So causation produces a strong correlation between two variables, but the opposite isn't true. In other words, correlation does not imply causation. And we're going to look at a couple problems together to make sure you guys get that. Let's look at example 2. For each situation, state whether it shows causation or not. If it shows causation, state whether it's positive or negative. First question. The number of correct answers on a test and a test score. What does that mean? That means, if I got a bunch of answers wrong on a test, will my test score go up or go down? Or if I get a number of questions right on a test, will my test score go up or down? I'm pretty confident with this one, guys. I'm going with A. This is a positive causation. As we change the number of correct answers, either up or down, that's going to take our test scores, and that's going to either push the score up or the score down. So A was pretty easy, I think. Let's take a look at B. The height of a person and their intelligence. So what you're saying is, if someone is super small, then they're super smart. Or if someone is super big, does that mean they're super dumb? I don't know about that. I'm not feeling that. I would have to go with this thought. This is not causation. For example, tall people are not necessarily more intelligent, and small people are not necessarily, less intelligent. Now, if you said the size of somebody's brain, that might be different. But how tall they are, I don't think so. How about C? The distance driven and the amount of gasoline that will be used. So let me think about this. Drive a long way, use a lot of gasoline. Draw a little way, drive a little bit, use a little bit of gasoline. That seems like a no-brainer to me. I think this causation. So this is positive causation. As I increase the miles I'm driving, I increase the amount of gas I'm using. As I decrease the amount of miles I drive, I decrease the amount of gas I use. Let's see if we can get some more practice with this. Which situation does not show causation? Is it A, when a student's population at school increases, the number of teachers at school increases? Is it B, when the amount of sugar in an apple juice is reduced, there are fewer calories in each serving? I'm pretty confident that's causation B. C, when there are more workers on a project, the project is completed in less time. Yeah, I feel C is a good one too. D, when there's more protein in an athlete's diet, the athlete scores more points in the game. Say what? I don't think so. All right, so let's look. A, B, C, and D. Absolutely B and C are causation. A is kind of iffy. My best judgment is to say no causation is visible in situation A or D. Because I do know when the students' population increase, sometimes more teachers are not hired. All right, and I do know that when we add protein to a person's diet, that doesn't mean they automatically score more points. Let's take a look at this next question. Next question. Which situation best represents causation? A, when the number of bus stops increase, the number of car sales decrease? No, don't think so. B, when fewer firefighters report to a house fire, the damage caused by the firefighter decreases? What? C, when ice cream sales increase, the incidence of sunburns increased? Or D, when it rains several inches, the water level of the lake increases? Okay, so guys, it doesn't take a rocket scientist to figure this one out. The only one that actually makes common sense is D. When it rains several inches, the water level of the lake also increases. All right, that's all I got for you guys. So, in summary, wanted to keep this under 5 minutes, and I'm at 10 minutes. It is what it is. All right, part 2 has concluded. 30 minutes, guys, of study a day. Keeps bad grades away. And we got to get really good at this regression stuff because there's at least 2 to 3 questions on the Regents exam that require us to understand this concept. All right, McCray out.